All right, so this is going to be the last of the project management lectures, and it's potentially the most important one because there are a lot of risks associated with projects or even life in general, and so there is a particular methodology for how one handles those kinds of things. So there's a lot of chance events, and any of those chance events can particularly affect your project. Um, if you don't know what Murphy's laws are, look it up. All right. Um, if anything can go wrong, it will. That's one of the fundamental Murphy's law. And other sort of sub laws about this is of the all the things that could go wrong, the one that causes the most damage will occur. So you can look those up. Now, the other one that I wanted to talk to you a little bit about in terms of why project management and risk management are one of the same is in the upper right hand corner. Lawn Chair Larry. And again, you can that this is a really that this is a real person, Larry Walters. If you haven't heard of the Darwin Awards, you should look that up too. Um, Darwin Awards. Larry Walters was awarded a Darwin Award, but only an honorable mention. In order to get a full Darwin Award, you have to die in one of the stupid things that you would do. Uh, and so Lawn Chair Larry, what he did was that he decided that he wanted to go ballooning, but he couldn't afford a full balloon. So he took a cluster of balloons and he tied it to a lawn chair, and he decided that he would take some food with him, and he would take a BB gun to pop the balloon so he could go down and control his altitude, and he thought he had everything under control. Unfortunately, he didn't do proper risk management. And what happened was that when the balloons were released, he had a quite a large net upward force, and it jerked him off the ground. He did not have his lunch or his BB gun sufficiently tied down as a mitigation for the risk of losing them, and so he lost them. So he had no food or drink, and he had no way to control his altitude. Um, he wandered into FAA controlled airspace in Los Angeles. There was a police helicopter that was scrambled. They shot at his balloons to bust them, and he came down, if I remember correctly, just before hitting the Pacific Ocean, uh, and was obviously arrested and fined and that sort of thing. So if he had done the proper risk management and identified issues like possibly his BB gun falling off, he probably would have had a slightly different story. So risks are undesirable events plus the chance this event might occur, plus the consequences of all possible outcomes. So a risk is not just something happen, but there are other aspects to that as well. And I've said this several times, and it's absolutely true. The essence of project management is risk management. There will always be unforeseen events which will happen, and you will run into them during this semester in your project. Now, the the chances of risks occurring as you go through your project varies over the project life cycle. So here is the project life cycle from initial development all the way through completion. And then on here, I've got two curves here. The chance of risk uh, from low to high over here with this curve, and then the cost to fix uh, a problem associated with that risk from low to high here. So obviously, as you go deeper and deeper into the project, if something bad happens, the cost to fix that significantly increases. The other side is that the chances that your risks are going to happen are relatively high early in the program where you haven't really started defining how you're progressing with your project. And so the chance of risk is very, very high for your project initially. And as you start defining your uh, requirements and your circuitry and getting into your schedule, that overall risk for the entire project goes down. So it depends. So the point is that defining as much as you can early on. I think I've told you that before. Really increases the probability of the overall success of your project. So risk management is to some extent a very straightforward process. There's the four major steps which are included in this. First of all, identify all the possible risk events that can affect your project. Assess each of these risks in terms of severity, how bad it would be to your project, the probability that that risk will occur, risk event will occur, and how can you actually control it, or what the controllability is. Identify a strategy or some sort of a contingency plan for dealing with these risks and responding to each risk. And then as you go through your project, monitor and look out for these risk events happening. This stuff is codified in what's called a risk management plan. And you should develop one of these plans early in your project and keep it updated as you go through the project. So how do you identify your project risks? Well, probably one of the easiest ways to do that is to brainstorm, get your team together and start thinking about all the kinds of events that would happen during your project. Now, remember that we're talking about risk events, not consequences. So here's an example. Instrument does not return correct data. Well, that's a result of a risk event. That's not the risk event itself. A risk event is that you have incorporated bad resistors in your circuit, or you didn't solder it correctly, or there is something that failed, or you forgot a subroutine out of your flow chart. Something like that. That is an event. Consequence is then that your instrument does not return correct data or some other kind of consequence. So you want to identify the events that will happen. Initially, you don't try to identify what the probability is. You just put all these out and list all these. First, try to focus on overall project risks, then go into specific risks. So this is sort of like where we talked about with your system design. Your system design starts with the overall project and then starts digging down into deep layers. And that's the same thing that you do with your risks. Your WBS, and here's another really good use for your WBS, and that can help you organize your risk identification. If you have a good WBS, then you can identify, go through each one of your items and say, okay, what are the risks where this step can fail? All right, and that will help you identify that. Go outside your group, go to your faculty advisor or other people, or maybe even if you have another team at your institution, you can consult with them. And always, always, always remember Murphy's laws. Critically, uh, 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 do critical thinking during this process. Once you brainstorm your events and you have your complete list of events, now you want to assess the impact. And there are 4 things that you will want to list for each event. So the consequences, list all the consequences of that event. If that event occurs, what are all the consequences and how bad each one of those consequences actually is? When would this risk event possibly happen? How likely would it happen? How difficult will it be to detect it? Okay, so those are the 4 fundamental things that go into a risk event. So here's an example of a matrix to try to identify that. So here's a number of risk events: interface problems, system freezing, user backlash. They don't like your user interface. All right, hardware malfunctioning, whatever it is. So the likelihood. All right, so what this team decided here is that the most likely that you'd have interface problems and user backlash, and the least likely is hardware malfunctioning. But if the hardware did malfunction, then the severity would be really high. Okay. Likewise, if your the detection difficulty would be a 5, it probably would be really hard to detect some detail hardware malfunction. You'd have to really go through and dig down into your hardware to do that. Likewise, interface problems may not be as bad. And then when would this happen? Okay. So startup, post installation, conversion, installation. So this is what you use in order to sort of figure out what kind of impact that your each one of these risk events would have. Then a risk severity matrix, like I'm showing here, is very useful for determining which of your risks that you really want to worry about. Um, and on this matrix, you put on your impact 1 to 5. So least impact is a 1, most impact is a 5, and the likelihood for a event to happen is 1, which is least likely, and 5, which is very likely. Now notice that the red region, so the red region is obviously the area where if you have a risk in there and it happens, you get maximal impact on your project. And the green is, probably those risks that you don't really have to worry about. That this is not symmetric, right? So in fact, severe events, right, even if they aren't as likely, are much more important to track than than really common risks that might not have as much of an impact. So that's why this is asymmetric like this. So obviously in the red zone, any risk events that you identify in this red zone, those are the ones you're going to focus on with your risk management plan. Yellow ones you probably do. The green ones, if you have any in the green, you probably don't really have to worry about those very much at all. So what are the methodologies for handling risk? Well, first of all, there's mitigation. So mitigation means that you're going to actively take action to either reduce the likelihood of the risk or the impact of the risk. So the example I have here is that if you if you get your electronic components in, then after you get them in, you would test each one of those parts to identify which are the bad parts. And the bad parts you would throw out, not use in a circuit. So that would be a mitigation methodology for incorporating for the risk event of that you've got a bad part in your circuit. You can think of other things where mitigation would potentially work. Like for example, you may have a risk event where you load the wrong software onto your payload. Well, one of the mitigations there would be to make certain that you have very stringent version control on your software, and everybody knows and witnesses which version that actually gets loaded. So that would be a mitigation for that particular risk. All right, you can, another strategy is to retain that risk. That this is usually done for very high impact risks which have a low probability of occurring. So nuclear war, okay, that obviously has a very serious and high impact, but the probability that that would happen is really low. So you would basically retain that risk, okay? And so, and probably put in a contingency plan just in case it does happen. Run, or get under shelter or something. You would have a contingency plan. But high impact, low probability events, you retain that risk. Sharing risk. This is very popular. Sharing risks, where you have multiple units associated with the project assume some portion of the risk. And then the one that student teams are very prone to do is transfer risk. So this is where a risk is assumed and managed by something else. So for example, a risk event where the balloon pops prior to reaching altitude. So that's a real risk event, and things like that have happened. But that's not your risk. That's my risk and Doug's risk. That's the LAESIS project management risk. So that risk gets, even though you could identify that as a risk event, that gets transferred off of your project into the vehicle system. So there's a variety of these kinds of strategies for handling risk. So part of your risk management plan would include how you're going to respond to these risks. So, and again, there's like 4 items that you would associate with each risk event. So what the strategy would be, how will the risk event be detected, and in particular, what would be the trigger that's saying, okay, a risk event is occurring, we have to put in our strategy. What plan you put into place in response to the event, and who is responsible. This is key. There has to be a person identified for the risks. So, probably maybe the way that you would handle this thing is that any software risks would be handled by need to be handled by the person who's doing the software. Electronics, your electronics person, mechanical, the mechanical person. So you would probably assign that person to be responsible for monitoring the risk and controlling it if they have to. But you'd produce another table similar to this for your risks. Now, I had mentioned the other day that when you do your cost and schedule that you don't include contingencies. It's in the risk management that you put contingency, not in your regular schedule. So when you have some risks which have severe outcomes, then you can put in a contingency plan that would help help reduce your risk. Like for example, here one of the examples I have is that have backups or alternate designs. All right, those would be contingency. If you have different kinds of sensors that would be appropriate for your project, you might have alternate sensors available in hand as a contingency in case you have to substitute those out. Many times you might have to deal with a risk with a trade-off. So for example, you are going to have a risk which is going to be something like cannot cannot achieve the CDR milestone. Okay, well, one of the things that you're going to have to do is that you're going to have to then do a trade-off. So what is it that you're going to have to throw out in order to make that milestone? Are you going to have to try to get more people involved? Are you going to switch your tasks to more efficient people? Whatever that is, that's going to be a trade-off that you're going to have to do in order to make that, in order to deal with that kind of a risk that you are making the schedule. Many times, risks associated with costs. So in your case, probably time would be a cost. That's from estimate errors. You can descope your options in order to make things go quicker because you're removing tasks from the primary mission. Or there might be other ways that you can handle that in terms of trade off the scheduled delays and lower costs. All budgets, your mass budget, your power budget, your schedule budget, your cost budget, should include a reserve percentage that can be expended as risk events occurred. So if you know that your FRR, complete FRR, is done at the beginning of May, you should plan on having that FRR done 2 weeks before. All right, or a week before, or some contingency before that, or some reserve before that, so that if and when you run into a problem, you can expend that time to make up your schedule. Likewise, in mass, you know that your limit is going to be 500 grams. So at this point, you should be holding a reserve of probably at least 10, probably 20% of your mass. So your initial design in the PDR should be showing a mass of something like 450 or 400 grams, all right, in order to have your reserve, that when things go later on the project, you can use up that reserve to make up your mass. All right, the risk management plan, all these pieces go into what's called your risk management plan. And you identify your specific person, you know what are the triggers for the monitors you have, what your response will be, and what your contingencies are. And so as you proceed through your project, you're going to be watching for those risks. The responsible person has to have the expertise and authority to identify and respond to these kinds of risk events. And then obviously report it to the rest of the team, and then put in place the contingency. So part of your documentation is going to be to discuss your risk management plan. All right, so there's a couple references that you can look for, and there's the reference for Murphy's Law. So